Start. Hello and welcome back to Calculus 1, section 5.3, Fundamental Theorem of Calculus. Yeah, know the title. Fundamental, right? Meaning very important. So what is the fundamental theorem of calculus? So far, we encountered all three parts of calculus. We talked about limits in chapter 2. We talked about derivatives in chapter 3 and 4. And now in chapter 5, we are talking about antiderivatives known as integrals. Fundamental theorem of calculus is uniting all of this. What we are going to see here is that the fundamental theorem of calculus has two parts. So, fundamental theorem of calculus part 1 is the process in computing the definite integral. So, I have integral a to b of f of x dx is equal to the antiderivative fx computed at a to b, which is f of b minus f of a. So this is fundamental theorem of calculus part 1. And we did many examples last class. It is just a calculation. You get the number at the end, and that's that. Fundamental theorem of calculus part 2 is the one that we need to discuss today. And that one says that the derivative of integral going from a to x of f of t dt is equal to f of x. Can anyone tell me what does this mean, essentially? What does it mean? Anyone? Yes? Very good. It very simply says that the derivative will cancel the integral, and then you just have your function as the answer. So that's technically what it says. So you have the pairing for numbers with operations. You have the pairing that addition and subtraction are opposite of each other. Multiplication and division are opposite of each other, right? So now for operators, operators change functions. Operations change numbers. So for operators, we have that the derivatives and integrals are opposites of each other. They cancel each other out. That's the reason that you can take the derivative once you're done with integration and then solve and then check if you solved the integral correctly. Now, I'm going to do the proof for this so that it's clear that this is what we get. Again, this is theoretical section. So I'm going to first integrate f of t dt, and what I get is the antiderivative of t computed from a to x. Now I will use the fundamental theorem of calculus part 1 to compute the given function, and I will get f of x minus f of a. Now we know that f of a is a constant because that's going to be some function with value a added in. Now a could be 0, could be 3, could be negative 10. A is something, right? So we plug that number in, so we understand that this is a constant. And then what happens when I take the derivative? Derivative of antiderivative is just the original function f of x, and you get minus 0, so you do get f of x at the end. And this is the proof for the red statement above. And that's what we have. Now, we can use this calculation and see it at work on a function. You can pick any function you want. Let's do, what should we do? Sine x, cosine x, e to the x, what should we do? X squared, I don't care. Pick one, something. Sine x it is. Sine t, sorry. So to apply this on a problem, we're going to take the derivative from some value. Let's go from 3 to x of sine t dt by popular demand. Right? Is that popular demand? No. Or whatever. So now we are taking the derivative of sine t, integral of sine t. What's integral of sine t? What's integral of sine t? Thank you. See, this is why I feel, so alone all the time. So negative cosine t computed from 3 to x. It is the derivative of negative cosine x minus and minus will give me plus cosine of 3. Now cosine of 3 is some number. You can change your calculator to radians and then just punch cosine 3 and you will get some decimals there. We don't actually care what the answer is because whatever it is, it's a number and derivative of a constant is 0. So we have a negative derivative of cosine is negative sine x, and then that's the 0, so we just get sine x. So you see, your input was sine t, your output is sine x, and that's what it means that f of t is the input and f of x is the output. It's the same function with a different variable. We call this kind of change in variable when you keep the same function a dummy variable, which is okay. And technically that's it. So you are getting the same answer on the other side. The last thing that I'm going to ask you is to do some brainstorming here and tell me why derivatives and integrals undo each other. So definition for derivatives, as you might know from your previous exam, is limit h goes to 0 of f of x plus h minus f of x divided by h. And from last time, the integral a to b f of x dx is given as the limit n goes to infinity of the summation I goes from 0 to n of f of xi delta x. By looking at these two formulas, can you tell me why are they opposite of each other? Anyone? Yes?
The upper one is got division and subtraction, and the bottom one is summation and multiplication.
Perfect. Do you see that? You all heard it? The top one has the subtraction and division. The bottom one has addition and multiplication. You see that? Of course they're going to be plus. This one goes to 0, this one goes to infinity. Everything is backwards. Everything is opposite, right? So that is just one nice confirmation on these two concepts being completely opposite. And that's that. Fundamental theorem of calculus are these two formulas here. And those two formulas are responsible for, those two formulas show, one shows the way to compute definite integrals, and the other one how to connect derivatives with integration, and then their opposites, which is further reinforced in their definitions. All right, let's start the stream, restart the stream for the second section 5.4.